Hello YouTube viewers, welcome to my channel Science Technology. In today's show, Science Thursday, we're going to talk about car headlight technology. So let's dive deep into it. So why do we need this? Well, sometimes we do need to ride at night. Now, back in the early days, there were two reasons never to do it. First, roads were not roads. Second, if anybody saw a light coming through, in the middle of night, they knew that it's a very good rich target. Every lawless individual just fired missiles at it. So it was really bad in the early days. But now we have reached more civilized civilization, so it does not happen that often. So night driving, especially inside the city, is like, bruh, who cares? And ideally, you do not even need, headlamps, simply because street lamps should be everywhere, but it's not everywhere yet. Heck, sometimes I have to drive on roads that do not even have road marking. So, lamps are like, whoa. So realistically, there are certain limits. Now, car moves at very high speed. And again, when I say high speed, I do not mean Autobahn level stupid speed. I mean speed. Like, you cannot stop a car if light that you are projecting is not that far. Like, you will think, oh, like, I'm driving at 50 kilometer, I can easily apply brakes. No, 50 kilometer per hour in daytime is very safe. Why? Because you can see everything around you. You're like, okay, oh, there is an animal crossing, let me slow it down. Oh, it crossed, let me accelerate. Oh, it's like, oh, it's really not going, let me apply brakes. You need time and distance to slow down, both vectors. Now, again, because in daytime you are seeing so far away, your brain is pre-calculating many things. But when you are driving at night, animal can just whoop, and you did. And it has happened. Like, that is the case. It's not like, oh, it's a once in a million. No. It's a common occurrence where you can just like, bam, you did. So that sort of thing happens because, again, at high speed, and I mean 50 kilometer per hour, which again is very slow in miles per hour. Yeah, you're not gonna go up. No matter what braking system you have, like anti-lock braking system with like giant calipers. It's like, it does not matter. Giant rubber patch does not matter. You cannot slow down because, again, law of inertia. So that's the serious issue, meaning you need to see, otherwise you cannot. So far, you need to see far. How far? Well, that depends on speed. 100 meters if you're traveling at slow speed, 200 meters if you're traveling at mild speed, 500 meters if you're traveling at any sort of decent speed. So you do need to see far, only then you are effective. Now, what is the penalty if you have a poor headlight? It puts everyone risk, including you and everyone else. For example, what if your headlight is like, just too dim and somebody was coming from the other side, they did not see you? And what if the opposite, it's too bright, it dazzled them, wabam, dead. So it is a serious thing that everybody has to take under, into consideration. So there are certain needs. It's not just lol, it's a need, like serious. And again, that is the reason why headlights are put into separate circuits, meaning your left headlight, right headlight generally have two independent fuses. The idea is, no matter what happens, the likelihood of both of them kaputting at the same time is zero. So again, it's a need. It's not a luxury, it's a need. So halogen technology. Now, this is the first high performance technology we got, first successful electric light, because again, before this, same wattage and all that, we used to have incandescent bulbs, big bulbs. And you can find some museums and you might find like big ass bulbs. They did not work very well. So this is basically upgraded version of that technology. So you still take tungsten, it's still a tungsten bulb, and you still heat that puppy up so incandescent, basically it starts to glow like a black body radiation. And exact same principle, as in like the filaments, they are working exactly like incandescent bulb, but they are under pressure, and they are under pressure with a gas mix, generally halogen gas mix. Halogen is a category in periodic table, so iodine or bromide is generally used, bromine, sorry. And the glass capsule, because again, you are keeping it at high pressure and high temperature, the capsules are generally not made out of glass. Like the glass you see in a household bulb is very thin. Glass here would be tough. It will be either toughened glass or flat out quartz, because it has to be very robust against temperature and very oomfish in order to handle the pressure. Yes, the pressure inside is higher than atmosphere. It is high pressure. Now, why do we put it high pressure? Well, it allows two things. First, high pressure and smaller volume makes your job much easier. If you have like this box, make sure this box is high pressure and high temperature, difficult. Makes this box high pressure easier. High pressure, and it allows them to run very hot, as in if you have only that much gas envelope and you are pumping 60 watts of heat in electrical energy into this, it will heat up. Now, what is the benefit of heating up? Incandescent is directly proportional to temperature, as in the hotter the filament burns, the more light you get. Penalty, it evaporates quickly, meaning your filament will not last longer. So if you keep hearing like people decided the bulbs should only last this many hours and all that, it was a what you call balancing act. Basically, they could run the filament much cooler, but you have to have like 10-20 bulbs in order to get light. Or they could have like, there was a balancing act. Same happened here. It's like, yeah, they could make the filament glow faster, but it will, if it breaks very quickly, what's the point? But this is the whole point. Tungsten evaporates, cool, awesome, but here's the deal. That's where halogen comes in. As in, you have tungsten, you're pumping electricity into it, it is getting hot, like bonkersly hot, and then tungsten yeets from there. Okay, it gets married to what we call tungsten oxyhalides, and it's a marriage, so it's not stable. It gets divorced, it comes back. So basically filaments recharges. So all the evaporation comes back and it recharges. So if you have to remember the good old days of bulbs, you must have seen there used to be a silver lining coating in the bottom area. That's tungsten basically evaporating, boiling away, meaning it will make the filament much weaker and over time kaput the filament. Here same thing happens, but it's much slower. Why? Because a majority of the filaments are coming back. The atom wise, basically the mass wise, it remains the same. And again, this reaction is far more easy to do if you are at high pressure and high temperature. Tada. Now let that be very clear, it's not fully filled with ionite gas. Generally you still have krypton and xenon, or like those sort of gases can be added to enhance the spectrum quality a bit. But majority component, the active component is halogen gas, now as in like mixture and all that. So, but there is a penalty. Even though this burns hotter and it does have a recharge cycle, it still boils filament away, as in the filament is slowly boiling off. Now, it will come back, but it will not come back exactly where it left off. Meaning if you have a filament, let's say a rod, it evaporated from here does not mean the atom will come back exactly here. It might come here. So over time, you will still have the same issue. It's just much slower. Meaning over time your filament will create a weak point and it will crack from there. So these things do have limited lifespan. Much better than filament, normal argon filled filament, but they are still not very long lived. They are much better than what they used to be. And we have made a point where it's like, you buy this, you rarely have to change them and all that. So, and this is another design. That's why they have two filaments, to make sure that whatever happens, the likelihood of both filaments dying at the same time is almost negligible. So, because again, what's better than having no light? Any light. So if let's say you are driving at full light, your low beams kaput itself, high beam. And again, high beam is not recommended, but you have some light. So flat out. And because this is such an ancient technology, the world is built around it. Like you can see, like why this has like two filaments. They are acting as high beam and low beam. Why it has like a cup there? The cup, this is H4 headlamps. Halogen lamps. The cup is for low beam, so it reflects the light. Now where it reflects? Reflector. Reflector is designed for H4 bulb, as in point source of light, meaning this is the point that glows. All the photons goes to the reflector. Reflector projects it into the road. Everything about that is calibrated and fine-tuned for halogen topology. So it's very cheap, it's very simple, world is built around that. It was technology, it is technology, and there is a very good chance for next 20-30 years it still would be in use, because it's like it's good, it's chill. And the two primary benefits it has that still is not replicable by something else is it's very voltage tolerant, meaning it does not care whether you're like 15 volts. It's like, I got this. Again, not recommended to put at 15 24/7, but like it's like, I got this, I'm like, me good, I got this. And you're like, what if temperature, like India's hot temperature, like 60 degrees Celsius? Like, bro, I do not care. Do not look into the temperature of the filament. It's bonkersly hot. So it's like, bro, I do not care. Like, I do not care. Temperature, it does not care. Voltage, physical shock, it does care. And you can see like the filaments are much stronger compared to your bulb filament, but they do have some weakness. And over time, they will weaken, because again, where the tungsten is evaporating away, it's not exactly the same spot. So they are very tolerant, they are very chill. Temperature and voltage wise, they are the king at this point in time. And they are 20% of electrical energy is converted into light compared to 10% of incandescent, normal argon filled low pressure incandescent bulb. So halogen was the king, and there is I think this will be the most longest lived technology. Unless we find something better than LED, I do not think so, but this will have the second longest life. LED will be the longest lived. So now we come to LED. Now LED is the world's first solid state. Xenon did, as in like high pressure arc lamp, so to say, they did came into market, but they were like very, what you call, poorly timed. They came too late and LED came just afterwards. So they did not become like a big mainstay. Like halogen, it came, it swapped everything. We are still using it. High intensity discharge lamps, not that many cars got it, and now we are replacing with LED. So that's why I'm not covering that. LED is the solid state emitter, meaning there is no emission by radiation, as like you're not heating it up, you're not incandescing it. You just have a P and N junction. So you have holes and you have electrons and you are just jumping there. Again, energy cannot be created nor destroyed. So when you are dumping it, you have to dump energy in some format. Generally, thankfully, it dumps it in photon format, aka light. Now it's a what you call solid state. There is nothing that is evaporating. There is no reaction. There is no fragility to it. Very long-lived stuff. It has best luminous efficiency, as in if you dump 100 watts of energy, 30 would be converted into what we call light. So lumens per watt is magnificent. Like there is nothing better to it. Now let that be very clear. 30% may not sound that great, but again, think in normal sense. 10%, 20%, 30 is like, whoa, half. So it is really bright, but again, that's why you still need cooling, because it's only 30% efficient. So, and you can go up to 40-45% efficiency. Like, okay, then why don't every bulb has that? You have to put lot of LED. As in, like, if you are making a floodlight, the best way to make sure your floodlight lasts much longer and it's very efficient, have double the number of LED cops, like the actual chip. If you run them just when they start to glow, like they are what you call not linked directly with voltage. They have a sort of S-curve. They're no glowing, they start to glow. So once you have that, just above that, keep there, you'll be shocked how efficient it is. This number can go up to 40-45%. The reason why normal bulbs don't do that, it would be expensive. Not driver circuit. They have to have just larger surface area, more diodes. So company fry it, and you can easily figure out, like, good branded LED, let's say it has 20 chips that are emitting light. Chinese 10. They are frying it. So that creates a double benefit. First, it's cheaper to manufacture. Second, it does not last longer. So you have to buy more. So if some company is like, okay, I'm going to make a LED lamp and I'm going to force all the light from small diodes, it's not going to last very long. And efficiency also drops. So, but again, most of the time you can expect 30% efficiency. If it's not doing that, they rush the design. But be mindful, because halogen is so old, we first tried to do something like this, as in like just, create a bulb replacement. It does not work. You have to do a lot of redesign. And another reason is everybody hates in India LED lamps, because most LEDs in India is aftermarket. And I would be not very confident in people's ability to replace the bulb and then calibrate the bulb. Like people just say, oh, I'm going to swap the bulb. That's not how it's supposed to work. You have to calibrate it. Like there is a laws, regulation. Every country, every jurisdiction has laws. And I mean seriously, like this law is designed in such a way that A, you get the full illumination ahead, and B, you do not blind someone in front. So, and again, you can easily find people with proper guides, as in like your headlamp is here, there are screw holes, like literally screw holes where you're supposed to put flip screw and tighten it. And you inside also your basically driver cabin, you also have a knob to adjust basically the alignment. You're supposed to do that. I have not seen that many people who have done that. So light is literally going like this. I'm like, what's the point? So fundamentally, it does require a lot of redesign. Now, so if you compare this to, let's say, Mercedes, BMW, Audi, they do redesign the basically whole reflector. So it optimized for LED projection. So that is the penalty part, meaning it is expensive from a company's point of view. They can't just swap it. They have to do the whole redesign, almost exactly like how intensity discharge required. They required a projector system. Here they require a new reflector system. So, and it does require cooling, because it still has what you call only 30% efficiency, and given the fact that it's heat is physically coupled, if you do not like, there is no gas envelope dumping heat away, it does not like high temperature. It works at very low temperature but does not like high temperature. So it does require cooling, and because it has a positive coefficient, as in like it heats up, it draws more power, it heats up even more, it burns itself out, it does require drivers again, as in it's very voltage sensitive. And you're like, no, it's current sensitive. It's voltage sensitive. Meaning, if you look into what a constant current circuit is doing, it's maintaining voltage. It's reducing voltage. Like, yo, it heat up, let's reduce the voltage. That's what it does. That's why, like, look at the S curve of LED output. Just a second. So it does require driver circuit and does require cooling. I have linked a teardown of a lamp. It has cooling fan, not one, multiple cooling fan. So it does require cooling and driver circuit. So why would anybody go through all this much trouble? Well, if you do that, like if you do it properly, as in temperature, as in this substrate temperature is kept reasonably enough and current is kept within reason, this will last the whole lifetime on a vehicle, meaning every part of your vehicle, including the metal chassis, will fatigue before the LED gives out. LED is like, bro, I got this. You give me right power, you keep me at right temperature envelope, I got this. Like the end, I got this. There is no discussion. It's like, it will not, have no issue. Like the diodes itself. So it lasts the whole lifespan. like really good, well-built system, you do not, basically you have to change the headlight when you are selling the car, nothing more than that. But let me be very clear, improper installation is a hazard. Again, if you are not following the rules and regulation, you will blind the someone else. I have literally, not joking, in foggy environment, I've seen someone's light like this. I was like, what the hell, bro? And again, you could do that from your cabin also. Like, there is a knob and it has a lot of range, like 4, 3, 2, 1. It's designed for that exact reason. So LED, but again, let this very clear. Sooner or later, everything will be replaced by LED. Why? It's efficient. As in, if you are doing it with an electric car, you will go at further range. You are doing a petrol car, you will get more mileage. So it will happen. It's just that hoping that aftermarket does not become the norm and corporations do it, so they will have some duty to follow the rules. Hoping for that. So now talk about the most hated technology, laser. If you think people hate LED, no, people hate laser. And like, wait a minute, did somebody smoked enough that they put laser? Yes. The idea is, what if you're not happy that it is night? What if you're like, hey bro, I don't like this idea. What if you glow up the whole damn thing? It's like, what if the night turns into day? So, or if you want to blind someone 500 meters away, or maybe even kilometer away. I'm not joking, this is a real photo by the way. If you are rich enough, you can buy what we call laser excited phosphorus flash lamp, and it has this sort of oomph. Not joking, like basically you can light someone up a kilometer away and they can read newspaper. And let that be very clear, it's not that it has more photons. The photon count is exactly the same. It just has zero spill. Like the next area, like if somebody is firing normal flashlight, you will feel it because everything will glow up. If somebody is firing this, it's almost like a laser. And if there is dust in the particle, you will see a beam. Like, it does not require beam from the lensing point of view. It does not require focus. It is a parallel beam. So it has very tight spot point. And it really uses very high power laser. How high power? Class 4 class laser. As in, many of the designs, they have this sort of a parabolic system, simply because if any component fails, it will stop the laser, right? Because if the laser light left the lighting housing, it will blind someone. Not joking, like it is that. You can look into Audi's lamp design, where they literally have a metal piece, like a big thick metal, where it's like laser is pointing there. If phosphor burns out or some accident causes an issue where this, like, whole thing kaput set, the metal piece will block it. And it's like, what if the metal piece broke? Metal piece is in safety circuit, as in if it breaks, the circuit will become open and light will not light. Like, this is a high power laser. Now, like, why the heck somebody will go through like lasers and then phosphors and then reflector? It does have two benefits because of the less throw it has. And again, a lot of people say that it has more efficiency. No. Laser diodes have less efficiency compared to LED diodes. Duh. Like, it is lower efficiency, but it has very high compactness. So like, throw wise, spill wise is zero. Spill is zero. So it does allow very small lighting housing. As in, if you have a motorbike, you do not have a lot of room. LED will require a lot of room to properly do it. This puppy is like, let me blind everyone. This size. So that's the physical reason why people jumped into it. But it has lower efficiency, meaning you are going, again, let's say it's LED, you are consuming 30 watts of LED power, as in like 30 watts of electrical consumption. With this, you will come back to 60. And again, they do have cooling fan, giant thermal blocks. I am shocked that nobody has started to put Peltier effect cooler, but they might. So this is a BMW. Again, I have linked the video down below. It does not show well in GIF. It's like, there is a road, and when BMW lights up, oh, this is the whole hill area. That's how big difference is there. And again, BMW has 3 LED, and to best of my knowledge, they have 3 LEDs, so they can turn off one or the another, so they do not blind the oncoming systems. It's not that good. Like, it does, like, light wise, if you are driving in an autobahn, this can allow you to drive at almost 200 km/h without too much hassle. It's like, bro, I got this. You can see, I got this. Like, I got this. But again, this is the most hated system, and I do not even want this anywhere. It's like, I get it, I get the desire, but no, this is too hazardous. This is like, I would buy this sort of lamp if some truck driver is like really flashing around, like, I'm gonna blind him. It's like, bro, die. It's like, let us go to Valhalla together. So this is laser, like, don't buy it, it's expensive. And I know your temptation, don't. So what can we expect in the future? Well, reality is we all have to switch to LED eventually. I just hope we switch from blue LED to purple LED. Now, like, wait a minute, all LEDs are white? No. There is no LED that is white. What you have is blue LED that dumps a lot of energy, and some of that energy is converted by phosphor mix into other colors. Penalty, you have a blue spike and then you have curve. So there is a dip. That dips make everything look ugly. And again, that's why people, even though lumens wise you have more light, people feel that they can't see very well, because again, it's not sensitive at the right wavelength. So halogen people still prefer. Again, you will find that, like, literally take every instrument and measure it. Halogen will be dimmer, but people will see clearly. So you want a better technology. Some companies are working on like true color LEDs, where they have, instead of blue, purple, and the phosphor mix has been changed. They are using in cinema movie lights. They are really good, like not that blue spike and then black. No, proper like smooth color. So I hope that becomes the norm, because again, there is another aspect of it. You do want warmer light, so you can really see. So, and I'm hoping that OEMs do it, original equipment manufacturer, rather than aftermarket. I do not like the idea of aftermarkets. And laser excited phosphor is just too risky. It's like, I get that, but no. Like if somebody is like, okay, which technology should not reach market? Laser excited phosphor is no. No. And BMW is like, no, but our was driving and we can shut it off. Everybody was complaining. Why they were complaining? Because again, a laser system is projecting light very far. Your camera, that onboard camera, yes, these lamps are so stupid, they require camera. Almost a self-driving algorithm. It's like, where's the car driving? What is the speed? What is the map? All that data has to go there, and then it detects a light source. Then it has to calibrate. Is the retro reflector or it's an actual light coming? Okay, it's actual light coming. Then it has to turn it off. But again, you fried the light. By that time, you would have already, thankfully distance does not drop the laser light. So they would have so everybody hated this. Again, you can't have a system that reacts faster than light. So it's stupid to even try. So that's why, like, I'm flat out against laser lights in public. And LED matrix systems, they are slow to react. Again, LEDs are not as brutal because it's not very sharp. Like, it does have spill, does have throw. So it's not disorienting compared to a laser system. So, Audi is like, we have the LED projection. This is modern Audi. I'm not joking. They have a cinema projector there. Not joking. Like, this actually projects the lane. Like, if you turn the lane, it will like, bro, just put an IMAX projector there. Like, just cut out the middleman. Not joking. This is what they're like. If you turn, it will literally follow the lane lines. Bro, do self-driving. That's more useful. So fundamentally, I do not like it. And again, this is like from Ford. It's like, what if you adjust based on the steering angle? And again, not the dumb steering, like, oh, you're turning. No. It's like, what is the speed? So based on that, it will turn. I'm like, just do self-driving, man. Like, just let it go. And self-driving, you have the luxury. You can use infrared light rather than harming someone else. And again, camera sensors can be far more sensitive than this puppy. So that also is there. And you can use LiDAR. So you actually know what's ahead. And radar, so you can know what is ahead far away. So that is there. Fundamentally, we want stable and efficient LED floods, which will happen eventually. It will happen. It's just that I find advanced optics to be extra costly, because like, okay, the LEDs will never doubt. Cool, awesome, cool, awesome. But here's the deal. What about something external? Let's say you build this system, right? You have this and that and GG, awesome. What if some rock chips the glass? You have to replace it. At that point in time, they put $10,000 replacement part. Not even joking. So that's why, like, I find it to like LED, new reflector design, a good LED system where you have a lot of cobs rather than like, one cob, you have roasting that cob. I do not like that design philosophy. Like, give me a lot of cobs, lots of it, like 50, 60 cobs. And again, even these matrix ones generally have 100 cobs. So you can go YOLO on it. Ideally, you should not require cooling fan. If you require cooling fan, redesign the damn thing. As simple as that. If you require cooling fan, redesign the damn thing. And yes, LED can survive even in Indian heat as long as you have a lot of cobs and you reduce the voltage. Don't, like, let's just say instead of driving at 3 volts, drive it at 2.8 volt or drive it at 2.5 volt. Yes, the cob count will go up. Reflector design will become more like a floodlight, but it will not heat up. It will last a much longer time, and to be cheap enough that people can use it. And I think that's another reason why halogen is not going away. It's like companies know how to design the halogen, but they have to calculate for it. And again, if you are buying BMW or Audi, you are rich. Who cares? But common people will care if they're like, wait a minute, you're telling me a tire is cheaper than my headlamp, which again, it's a consumer item because things will happen to it. So I genuinely do not like that. What if we have this? It's like, just give me a good LED floodlight, good throw, good contrast so it does not blind oncoming traffic. The end, go home. I have no idea. Like, what if we have a cinema projector there? It's like, what if you don't? What if you don't? So this was my presentation on basically lighting technology that is happening right now in the car industry. Hopefully you have liked it, learned from it. In that case, please click the like button, share it amongst your friends. That will help me a lot. If you didn't like it, didn't enjoy it, I urge you to press dislike, press it twice to show me disappointment. Please leave a comment because I do try to reply to all of them. Subscribe, press the bell icon if you're free, and as always, thanks for watching.